function we have here is f of x is 2x minus 1 over x plus 3. Our goal is to find the inverse and to check that using compositions. Now, remember, there's certain conditions we must meet to determine if a function has an inverse. So I want to take a look at the graph of this function f of x, and I'm going to use Desmos this time. So we go to f of x equals 2x minus 1 divided by x plus 3. And looking at this graph, we ask ourselves whether or not it satisfies the horizontal line test. If a horizontal line cuts a function in more than one point, it does not have an inverse. The reason for that is because to find an inverse, x becomes y and y becomes x. So if the original function fails the horizontal line test, when you change x and y, y and x, the new one will fail the vertical line test, and that's not a function. So the only way we have an inverse is if horizontal lines do not hit a function in more than one point. And I can draw on a couple horizontal lines. For example, y equals 4. It looks like that hits in one point, right? If I would draw in y equals -2, it looks like that one hits only in one point. And the fact of the matter is these are asymptotic. So this is getting virtually horizontal, but it's getting closer and closer and closer to that line y equals 2 without ever actually hitting it. The same thing happens over here. So yes, this does satisfy the requirements of the horizontal line test. No horizontal line intersects the graph in more than one point. Therefore, it will have an inverse. Now, how do we find that inverse? We've got to do some algebra. So I'm going to rewrite this using xy notation. Y equals 2x minus 1 over x plus 3. And the whole idea of an inverse is x becomes y, y becomes x. So I'm going to make that substitution. X equals 2y minus 1 over y plus 3. And then my goal is to solve for y. So I'm going to multiply both sides by y plus 3. So x times y plus 3 here. Over here, 2y minus 1 over y plus 3 multiplied by y plus 3 here. And you will notice on the right-hand side, the y plus 3's divide out. So now what do we have? We have xy plus 3x on the left side. On the right side, we have 2y minus 1. Now again, my goal, remember, is to solve for y. So I need all of the y's on one side and all of the x's on the other. So there's a couple ways we can do this. I expect most students would do it this way. Subtract 2y from both sides, then we'll have all of the y's on the left side. And then subtract 3x from both sides. And what goes away, what subtracts out? 3x plus negative 3x goes away. 2y plus negative 2y goes away. So now I have xy minus 2y equals -1 minus 3x. And again, there is another way you can do this, but I think this is probably the way most students would do it as you're learning this for the first time. Okay, the goal again is to solve for y. So right now I have xy minus 2y equals -1 minus 3x. To solve for y, I'm going to factor a y out of the left side. Dividing y out of xy, I get x, minus dividing y out of 2y, I get 2, is -1 minus 3x. And then I finish this by dividing both sides what's multiplying y, which is x minus 2. So I get y equals -1 minus 3x over x minus 2. What was our process again? If we look at this whole thing, we rewrote it as y equals, replaced x with y, y with x, did the algebra we needed to do, and then we solve for y. And after we solve for y, that result is our f inverse function. So we conclude by saying f inverse of x is -1 minus 3x. over x minus 2. Now, how can we check this? Our original function f of x was 2x minus 1 over x plus 3. I want to look at the graph of both of those functions and see what we can identify. So I will put in the original function, which I'll call f of x, equals 2x minus 1. Divided by x plus 3. And that is in purple, looks like on my computer here. The function that was f inverse, I'm going to just call g of x to make Desmos happy. We had negative 1 minus 3x divided by x minus 2. And that is in black. And what do we know about inverse functions? What's supposed to happen? The two functions, the black function and the purple function, are supposed to be mirror images of each other along the line y equals 1. Check that, y equals x. Can you see that mirror image behavior? That this point on the black function is mirrored with this point on the purple function. This point, what is it? It's like 9, negative 3 on the black function should be at negative 3, 9. Where is that? Maybe I misread that. Let's go ahead and look at it a little bit more closely. 1, 1, get rid of those. So this is the point I want to look at, is it's 9, negative 4. So you see 9, negative 4 is on the black function, which we thought was f inverse. So if I switch that, that negative 4, 9 should be on the other function, is it? X becomes y, y becomes x. Is negative 4, 9 on the purple function? Well, I can't see it until I adjust my screen, and indeed it is. So that's one way to kind of check it to see what it looks like. There is another way that's equally interesting. So I'm going to rewrite f of x. And there you see the purple function is f, and the black function is f inverse, which we're calling g. What's the other way I can construct the inverse function? Now, this is not solved, but this gives me a graph. Remember, x becomes y, y becomes x. Desmos enables me to define the equation that way. So x equals 2y minus 1 divided by y plus 3. And this should be the same graph as the black graph. So it's coming in as green, should go on top of the black graph. And you can see that's exactly what happened. So that's a way to check our work. So let's just one more time look at our process that's involved here. What did I need to do? Started with the original function. I wanted to find its inverse, but before I'm going to spend a lot of time on finding its inverse, I want to make sure that it passes the horizontal line test. No horizontal line can cut it in more than one point. And that's what we saw with our original function. Our original function was this one. And indeed, no horizontal line cut it in more than one point. Then what did we do? We rewrote f of x as y first, and then x becomes y, y becomes x, and solve for y. Multiply by the common denominator, distribute, get all the y's on one side, get all the non-y's on the other. This is where some students tend to have trouble. Getting all the y's on one side, all the non-y's on the other. So I had to subtract 2y from both sides to get all the y's on the left, subtract 3x from both sides to get all the x's on the right. And then the next tricky part is to factor out the y. Once all the y's are on the left side, now I have y times x minus 2 is negative 1 minus 3x. And then that finishes. How does that finish? Just divide by what's multiplying y, divide by the x minus 2. I get y is negative 1 minus 3x over x minus 2, and that is the same as f inverse of x, negative 1 minus 3x over x minus 2, compared to our original f of x, 2x minus 1 over x plus 3. And remember that when you graph the function and its inverse, they will be mirror images along what line? Along the line y equals x.